Okay, on to lesson 7 in Unit 1. Again, talking about linear scale factors, surface area, and this time volume. So we're going to investigate the relationship between the linear scale factor and surface area scale factor here. And we'll introduce volume in a bit. Part A, complete the following to investigate the relationship between linear scale factor and surface area factor for the following rectangular prisms. So, excuse me. If we look at this table, we have original dimensions, original surface area, linear scale factor, the new dimensions, and then the new surface area. Okay, so we've got a prism here. Notice we're multiplying three things together this time because this has volume rather than just a plain piece of paper or photograph. So it has height as well as depth and width. Okay, excuse me, this is a 3 by 5 by 1. So the original surface area, it's got 6 sides, just like a cube. One side is 3 by 5, another side will be 3 by 1, another side will be 5 by 1. And there'll be duplicates of those 3 sides to make up 6 sides. So if you think about it, 3 by 5 is 15, times 2 is 30. 3 by 1 is 3, times 2 is 6, so that's up to 36. And a 5 by 1 is 5, times 2 is 10, so we'll go from 36 to 46 for the original surface area for all 6 sides. If we apply a linear scale factor of 2 to 1, that means all these dimensions here get multiplied by a factor of 2. So instead of having 3, 5, and 1, we'll go to 6, 10, and 2. My pen is rather thick here. Let me just try and see if I can change it. Seems to be a problem here. Doesn't want to change for some weird reason. Let me pause for a sec and figure out what's going on. Okay, I think I've solved that. So, yeah, 3 by 5 by 1 is now at 6 by 10 by 2. So thinking of the surface area, new surface area again, be 6 times 10, and 2 of those. So 60 times 2 is 120. That'll be 6 times 2 is 12, times 2 is 24, so 120. Let's just write this down. 120 plus 24, and then we have 10 times 2 is 20, times 2 is 40. So there's 2 of those sides, and adding that up, we'll get 4. Okay, 4, and this adds up to 8, and 1. So this is correct, 184. Surface area scale factor. Now the new surface area compared to the original is 184 over 46, or in this case, 4 to 1. So again, it's gone from 2 to 1, the linear scale factor, to an area scale factor of 4 to 1. You'll find this is the case that will happen in each of these cases. So if you've got a ratio of 1 to 6, the scale factor here eventually will be 1 to 36. Just like before when we did the area, it's really the linear scale factor squared. This one is 3 over 2, so this will be 9 over 4. If we compare the new dimensions and their surface areas. And then 2 over 3, squaring out becomes 4 over 9. So you can fill the rest of these in. This next one will be 18. Oh, sorry, let me just erase that. So the scale factor is 1 to 6, so really we're dividing by 6. So, okay, 9 divided by 6 is going to be 3 over 2 by 6 divided by 6 is 1, and 12 divided by 6 is 2. So that'll be the new dimensions, and then you can work out the new surface area. Okay, I'm just going to skip ahead here. Let's compare the linear scale factors on here. Compare the linear scale factors to the surface area scale factors and complete the following. Surface area scale factor is equal to the linear scale factor squared. Now we know that already. Okay, from the previous lesson. Look now at the linear scale factor and volume scale factor. So what's happening here? Linear compared to volume. Well, here's the original dimensions. The volume would be 3 times 5 times 1, or 15. Let's use a linear scale factor of 2 to 1. So all the dimensions go to 6 to 10 to 2. Here we are. What's the new volume? Multiply this together to get 120. So 120, the new volume over the original, is 8 to 1. Okay, so remember with the surface area it was 4 to 1 when we used the scale factor of 2. Now we're at 8. Let's go down and just try this one, for example. We have a scale dimensions of 4, 8, and 5. So the original volume would be 4 eighths of 32 times 5, that's 160. Now what if we apply a scale factor of 3 to 2? That will mean we multiply by 3 and divide by 2. So 4 times 3 is 12, divided by 2 is 6. And then it's really 1.5 times, isn't it? So 8 times 1.5 is 12. And 5 times 1.5 would be 7.5. Would be the new dimensions. What's the new volume? Well, I may have to get my calculator out for this, but I think 6 12s is 72. So 72 times 7.5 gives me a new volume of 540. Okay, so let's check out 540 divided by the original volume of 160. And what do we have? 540 divided by 160. I hope I'm doing this right. No, doesn't look like it. Let me just pause and check my calculations. Okay, well in fact, this is correct. So we do get 540 over 160, which reduces to 27 over 8. If you go to decimals, it's 3.375. Well, notice what's happening. Notice the scale factor 2 went to, with volume, a scale factor of 8. This scale factor of 3 over 2 went to a scale factor of 27 over 8. Really what we're doing here is we're cubing this number to get 27, and we're cubing this number to get 8. Just like we cubed 2 to get 8 here. So let's look at the question below, which is asking compare linear scale factors. Compare linear scale factors and volume scale factors. Well, volume scale factor here is simply the linear scale factor cubed. Okay, so summary here. Linear scale factor is a ratio in the form of A to B, or A over B. This ratio describes an enlargement or reduction in one dimension and can be calculated using new length or original length. Perimeter scale factors is a ratio in the form of CD, or C over D. This ratio describes how many times to enlarge or reduce the perimeter of a figure. perimeter scale factor can be calculated as new perimeter over original perimeter. And in this case, the perimeter scale factor equals the linear scale factor here. So they're equal in this case when we're doing perimeter. If we do area, we can get new area over original area as a scale factor, or we can simply, to get the area scale factor, we can simply take the linear and square it. Surface area is the same, new, because this is area, still dealing with area. So new surface area over original surface area. If you're looking, say, for example, surface area of a cube, you can take the linear scale factor and square it to get the area square factor. And volume, as we've just seen, the volume is, we're going to take the linear and cube it. So the volume scale factor is the linear scale factor cubed. So we have scale factor relationships right here, stating that for perimeter, the scale factor is equal to the linear. For area, you take the linear and square it. For surface area, again linear and square it. And if it's the volume, you take the linear scale and cube it. Okay, so in class, I'd like you to do all the questions related to this lesson 7. And we'll see you in class tomorrow.